Hello, everybody, and welcome to our new chapter, lesson 4.1, and it starts in your textbook on page 199. And so what I decided to do is make 3 lessons in one, because for each lesson, I'm only showing you a few problems and maybe a couple homework problems. So we're kind of skimming through it. So this is on, the whole chapter is really on parts of triangles. So I'm hoping my thing works now because it didn't work all day. Of course it doesn't. Let me get this fixed. Hopefully it'll work. Come on. All right, mid-segments. Nope. All right, let's try this one more time. So we have mid-segments. So this whole chapter is on triangles and the parts of triangles. And this lesson is on what's called a mid-segment. And so a mid-segment, if you look on page 199 on the bottom, you'll see that you have a line that goes through the middle like that. And those 2 lines here are parallel. The bottom and this mid-segment right here, they're parallel lines. And the way you can tell is that this segment from here to here, from A to D, and from D to C, they're equal. See those tick marks? They tell you they're equal. And then if you go to this side, from C to E, and from E to B, those are also equal, and that's marked with the 2 tick marks. And if that is so, then the mid-segment is exactly half of the opposite base here. So that's the relationship, and that's called the triangle midsegment theorem. Not a big deal that you remember that word, but I want to highlight it anyways. So I'm reading the theorem. If a segment, which is a segment has a beginning and an end, this is a segment, joins the midpoints, which D and E are the midpoints between from here to here halfway and from here to here halfway. If a segment joins the midpoints, underline that word, of 2 sides of a triangle, then the segment is parallel to the 3rd side. Remember I told you these 2 are parallel, and is half as long. So that's the main thing. So for example, if this side is 10, this side would be 5. That means that that's the relationship, right? Half as long. Or twice as long. If you look at AB, that's twice as long as DE. So that's important. So let's underline that. If D is the midpoint of CA and E is the midpoint of CB, then DE and AB are parallel, and DE is half of AB. Okay, so that's page 199, and then I'm skipping straight to page, let's see. I'm skipping to page 202. Why do I do that? Oh yeah, here we go, 202. I believe I want to do number 3. So I'm looking at this triangle and I see you have a mid-segment. It's this one, right? And I know it's the mid-segment because these 2 parts are equal and these 2 parts are equal. That has to be true. So there's a relationship between the mid-segment and this base. And remember, the mid-segment is half of the base. So whenever you have to find x, you know you have to write an equation. So I'm going to say that 5x is half of 45. So that's my equation. This is half of that. Or you could say 45 is twice the mid-segment. Those 2 are the same. Which one do you like better? I'll solve both and you can see. So I'm going to draw a line here. This says or. 1/2 times 45 is half of 45, which is 22.5. right? Half of 45. And then you divide both sides by 5. And x is 11.25, I believe. Let's try this. 45 is 2 times 5 is 10x. Well, that doesn't work out. These are not the same answers. So somewhere I made a mistake. I have to check that out. So x is in this case, so that should match half of 45. So let me try. Yeah, no, it's half of 45. 5x, this is half of that. So I need to multiply that side by 2. Half of 45 is 22. Oh, that's weird. Oh. Do you see what I see? I made a mistake here. 22.5 divided by 5 is certainly not 11.25. I divided it by 2. So that would make it 4. 5 goes into 22 4 times. And then 2.5 divided by 5 is 4.5. 22.5 divided by 5. Yeah, 4.5. So notice it works either way, how you like the relationship better. I have a feeling you like the second equation, it's easier. So x is 4.5 in either case, how the relationship works. And then let's try number 4 really quick. So you have your mid segment. Remember, it has to be half here and here and here and here. That has to be in place. Otherwise, the whole relationship doesn't work. So I'll say 17 is 2 times the shorter side. 17 is twice this. Or you could say the shorter side is 1/2 of 17. But I'm doing it the easy way. I'm going to multiply this out. That's called distributing. 2 times x is 2x. 2 times -4 is -8. I will add 8 to both sides to undo the equation. 17 plus 8 is 25, right? Divide by 2. And turns out x is 12.5. Half of 17 is 8.5. Yep, works out both ways. Okay, so there it is. This is how you set up these equations, but you do need to check that this is really the mid segment. In other words, it's in the middle between those two endpoints, and that you have to look at these markings. These markings will tell you that. And then I will go to the next page, 203. I want to do this lake problem. Because surveying, you know, you've seen those people on the side of the road with these little machines they look through and they check out the property lines, they check out when they build a road where they're going to put it. And a surveyor needs to measure the distance PQ. So I'm looking at this distance across the lake. So this is your lake. He wants to know how far is it across, too far to measure. Beginning at point S, she locates the midpoints of SQ. So there's the midpoint of SQ. So these two are equal. And SP, so there's the midpoint of SP. So these two are equal. So this is your mid segment, okay? She then measures NM. So apparently this is a shorter distance. You can measure it with a tape measure. It's 78 meters, but you can't measure it across the lake. So she knows now that this distance is twice this one. So PQ is 78 times 2, which is 140 plus 16, 156 meters. Okay, so that's an application how you might be able to use that. So for homework on this lesson, go to page 205 and then look at the kayaking problem. So this is page 205. You only have one question. I'm going to check it. Make sure you get it. If you don't, then I'll help you. You want to paddle your kayak across a lake this way, right? To determine how far you must paddle, you pace out a triangle. Here it is, counting the number of strides as shown. Your strides average 3.5 feet. What is the length of the longest side of the triangle? I guess the longest side of the triangle. Oh, that should be this one. That looks like, I think they mean find this. Maybe this one. That's weird. It really has nothing to do with the midsegment. As far as I can see, I misunderstood that question. Okay, so here's the clue. These are strides. This is feet. And then, oh, here it is. What is the length of the longest side of the triangle? So you want this length in feet. And then you have to find the distance you must paddle across the lake. So then you find this distance. So two-part questions in feet. Okay, so change your strides to feet for both answers. Okay, that's the question for this lesson. And then we're moving on. Let's see, I think that's it. Yep. We're moving on to lesson 4.3. So skip 4.2. Bisectors in triangle. So the word bisector, this is page 215. Page 215, get there quick. And the word bi always makes two equal parts. Whenever you bisect something, you make two equal parts. Okay, it's either angles or segments. You can cut an angle in two equal parts, or you can cut a segment in two equal parts. And again, it's talking about triangles. Okay, let's look at our concept here. This looks concurrent means, what does concurrent mean? Equal, I think, and they are concurrent. Oh no, they meet, sorry. When they're concurrent, they meet in a point, like this is concurrent. You notice how they all meet in one point, and that point is called the point of concurrency. Not a big thing, you know that or remember it. Okay, so, and then we need to remember the word perpendicular means at a right angle, and bisector means cut in half. So perpendicular bisector is a bisector that's at a 90-degree angle. Okay, so the concurrency of perpendicular bisector theorem says that if you take the midpoint of a segment and you make a perpendicular bisector and you do that to all three sides, they meet in a point right here in the middle. And moreover, this point is equidistant or the same distance from the vertices. That's a little complicated. So this point is the same distance to the corners. Not to the sides, but to the corners. So for example, if this is 5, this is 5, and this is 5. I'm just coming up with a number, okay? So perpendicular bisectors of the side meet at a point in the middle, and that gives you the same from here. If you're standing here in a triangle, you got the same distance to all three corners. That's what that means. And here's another picture. Okay, so let's go to, let's see where I'm leading you with this. I'm going to page 218. 218, oh, skipped. Bisectors, we got that one. There it is. Is that it? No, 217. What was I going to do on that page? Oh yeah, So look at the page 217. On the bottom, you got a park. So the town planner wants to place a bench equidistant, which means same distance. Same distance from the 3 trees in the park. So you got 3 trees, and somewhere you want to place the bench that it's the same distance to all 3 trees. Well, that's your perpendicular bisector. So you're going to create 3 perpendicular bisectors. Of all 3 sides. So remember, the word bi means cut in half. So I'm going to cut each side in half, and I'm just estimating. We're not using a ruler. And then go perpendicular, perpendicular, and perpendicular. So it's all 90-degree angles. Looks funny, huh? And this point is the one that's the same distance from all 3 corners. So this distance and this distance and this distance is the same. If you put your bench right here, you'll be the same distance from all 3 trees. And I don't know why they put this here. Am I supposed to graph this? Do they say anything? No. I'm just using this picture. Perpendicular bisectors of all 3 sides. Go to the next page, 218. Over here. No, what page is this? 222. Maybe I'm skipping around too much. 216, and then we did that. 217. I guess I'm going straight to 223. Maybe I couldn't find a homework problem for you on this lesson, and I'm skipping straight to the next lesson. Yep. Oh, but I did. I saw one on 222. Oh, here it is. Noise control. There it is. Found it. To page 222. So the homework problem for this one little perpendicular bisector is the noise control, the problem 18. So let's read. So this is homework. You're trying to talk to a friend on the phone in a busy bus station. The buses are so loud that you can hardly hear her. Referring to the figure at the right, should you stand at P or C? So should you stand here or here? To be as far as possible away from all the buses. Explain. So you're going to use the same theorem I just showed you. You go to the midpoint of all 3 sides. So you estimate. Oh, look, it's giving you, I think this is the midpoint, but you need to find that one, and this is the midpoint. So you need to find this perpendicular and then connect it and see where you end up. So you only need to find perpendicular bisector here. And then go out and see where you connect, either at C or at P. See how they already did this one, this side for you and this side. Okay, so that should be fairly easy, I hope. Next page is 4.4, medians and altitudes. So sometimes we talk of altitudes as heights. Median is always something in the middle, and altitudes is sometimes called a height. Okay, and let's look at our little example here. A median of a triangle is a segment whose endpoints are a vertex, a corner. So you start at a corner and you go to the middle of the other side. That's a median. So you start at a corner and you go to the middle of the other side, and you start at a corner and you go to the middle of the third side. Then you have all three medians. And so here it's showing you the picture where you have all three medians, and again, they all concur. Concur means they all meet. They all intersect at the same point. Concurrency means all lines meet at one point. And there it is, right? And it doesn't always happen. Not all lines inside a triangle will meet at one point, but the medians will. The medians of a triangle are concurrent at a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. So that's important. It's not half like the first lesson in this, the first chapter. The first lesson in this chapter, it's 2/3. So I'm going to show you how to deal with that, okay? By the way, this is called the balance point. But if you cut out a triangle and find that point of concurrency and balance your triangle on your finger, it'll balance. So this is your balance point. Right there, okay? All right, so let's look what this is about in a couple examples I have. So this is page 225. Nope, I'm starting on 224. I want to show you number 1. That's called the centroid, by the way. This is your centroid, but it doesn't matter. That's your balancing point. So these are all medians. You can tell because you start in the corner and you go to the middle of the opposite side. Start in the corner, go to the middle of the opposite side. Start in the corner, go to the middle of the opposite side. Median. All right, so we have some information. YU is 3.6. YU, this part, 3.6. I'm labeling my picture. Find ZY. Find this. Okay, so remember the relationship is 2 to 3, 2/3. So this is 2/3 of the total. 3.6 is 2/3 of the total distance or total segment. So if you think about it, you can cut it in 3 equal parts. This is the first equal part, second, third, because 2/3 means you got 1/3 plus 1/3, and then plus another 1/3 is the total. So how much is 1/3? 3.6. If we divide that into 2, I get, I need to use my calculator on that one. $1.8. So if I have 1.8 for that, and I have 1.8 for that, and then I have 1.8 for that, then the total distance is 1.8 times 3. 5.4. Okay, so let's answer the question. So I got my 3 parts, and 2 of them is 3.6, 1 of them is 1.8, and the total is 5.4. So ZY, this part, is 1.8, and ZU, the total, is 5.4. Okay, that's the relationship. 2/3 of the total would be 3.6. And from that number, I find each part, 1/3, 1/3, 1/3. I'm trying to figure out another way to explain it to you. So how about this? 3.6 is 2/3 of the total, which is X, because I don't know it, right? So I can solve for X, multiply both sides by the reciprocal. This is another approach. This reciprocal, this cancel out. I have X equals 3 times 3.6 is 10.8. And then divided by 2 is 5.4, which is your total, 5.4. Well, there's another way to write it. And I'm going to move on to, let's see what our next page is. Do we have anything here? No. Oh, you know what, I do want to go over this altitude stuff, identifying altitude. An altitude is, it starts in one corner and goes to the opposite side, but it's perpendicular. So this right here, I'm just showing you, not a big deal, is called the altitude or height. So that comes in when you find the area, you have to multiply the base times the height divided by 2, and that gives you the area. So that altitude starts in one corner, is perpendicular to the opposite side. Okay, just to show you. Let's see, we have, go to page 227. And we're going to do number 7. Is AP a median or an altitude? Okay, look it up. I just explained it. And number 8, if AP is 18, what is KP? This is a 2/3 versus 1/3 problem, because this is the median. This is 2/3 of the whole thing, and this is 1/3 of the whole thing, and the whole thing is 18. So you have to figure out how much is AK and how much is KP. So I'm asking you for both, actually. Remember, it's the median. Okay, so that's this. Let's see if I have more on this lesson. Nope, we're moving on. I think that's it, actually. That might be my last slide. Yep, that's it for all 3 lessons, 1 little video, and you only got a few problems, but I'm expecting to see them. And if they're not quite correct, you try your very best. We can always correct it, okay? But try your best to figure it out. Good luck.